you. Oh, I need that energy because I'm feeling very woo. Anyway, point is, welcome to my talk, Understanding the Successes and Pain Points of Different Testing Strategies by me, Benjamin Bryant. So, as I just said, that's my name, and I am the organizer of London Gophers, which is a Go community in London, and I'm also the Go developer advocate at JetBrains. So a quick prologue, I want to just go into this to try and highlight some of the writing difficulties I had when putting this talk together, to maybe hopefully humanize myself a bit. Because this talk was a dilly of a donut to write. Because essentially I'd wake up and I'd start typing and I'd feel like this is fire. I'd be really into it. I'd get like 20 slides in, and then 2 days later I'd read it and be like, this is the worst thing I've written in my life. Why am I doing this? Am I really just, ugh. And then so my life essentially became a bit of a quantum superposition, endlessly flipping between this is fire and this isn't it, because I legitimately got a bit of writer's block. And I think part of it is because I felt I was going to be saying a lot of obvious stuff. And I think it's because when you talk to people who might be like more advanced than you in certain areas and they say things in a very matter-of-fact way, you start to question yourself and think, oh shoot, is this something I should have known? Am I really just going to go on stage and say that the sky is blue? But eventually I decided, screw it, the sky is blue, but I discovered that today and I want to talk about it. And I feel like adopting that mindset really helped me like get through writing this talk. And first of all, I just want to go over what this talk is about. Long story short, I chatted to people of varying skill levels for about 30 to 60 minutes and asked, do you enjoy testing? That's the entire methodology. That's all I did. And so it was mainly people who'd be between junior and staff level engineers. A lot of them were Go developers, some were using different languages, but I didn't get a chance to talk to people who worked exclusively on front-end testing or security, so things such as UI testing and fuzz testing and things will not be covered here, and this talk might be biased towards certain viewpoints. So what to expect? Well, there are two parts. One is the testing overview, where I'll basically be going over the types of testing that exist and exploring their successes and pain points that I got from the people who I interviewed. And then part two will be summing up some thoughts, observations I had after going through this process. So let's start with part one, the testing overview. And just to be clear, what I mean by successes is what people enjoy, pain points, what people do not enjoy, and remedies was a thing where people expressed a pain point and maybe talked about how to address them. But the thing about these remedies is that similar to real life remedies, in some cases it could be very effective, in some cases it could be ineffective, and in some cases where the patient might already be dead, it would be completely useless. So, now we move on to the very first one, which is unit testing. So if you don't know what unit testing is, I kind of see it as like, imagine you have this little service here, UI service and database. Your unit test would be everything within the service, as in like the service doesn't call out any like staging environments, any external things, any third parties. It's just anything that you can open your laptop and run those tests without talking to anything. That encompass a unit test. And so a very simple example is, imagine you have an add function. You might create some table test for it. This is just 3 add 5 is equal to 8. Super simple, that's a unit test. So what is it that people kind of like about unit testing? In theory, they are the simple and fastest form of testing that you're going to be doing, and they're typically seen as the quickest and fastest of the different layers of test suites. Again, another success is that they are local and have low setup costs. And by local, I mean to the service or project you're working on. And in the case where you don't need access to another team project to run these tests or hit a database that's in the staging environment or something, you as a developer can open your laptop, click run, and then the entire test suite should just work. So what are the pain points that people have with them? They can easily become way too numerous and very brittle. If you unit test every single part of your program but don't really think about the tests you are creating, it can maybe feel a bit pointless and can make refactors quite painful. And it can be quite difficult to write them well. A project's unit testing suite can sometimes be seen as a hindrance if they're not written particularly well, as in it can be tricky to understand why they've broken, where they've broken, and how to fix them. Now, this pain point might not be as valid, as essentially this point is true across everything, but if your unit tests aren't structured well, these issues can sometimes bubble up to higher levels of testing. And so some of the remedies that people suggested was the idea of maybe reducing unnecessary tests and putting time into choosing what to test. So unit testing can be an excellent tool for ensuring the different hypotheses of your system to make sure things are working the way that they should. But sometimes they can be viewed as you need to unit test all of the things, which might bog down people's willingness to do them. If you or your team members start to view unit testing as a chore instead of the boon that it is, that can affect the quality of the tests. So increasing the thought into what you want to test and why it's a good thing, that could improve your view and your team's view towards unit testing. Another thing that was suggested was the idea of trying not to test everything in one and keeping tests focused. This relates more to tests that seem to have everything in one single test. And as in, if something breaks, you have to dig really far into the test to try and figure out what exactly broke. If a unit test fails, it should be incredibly easy to identify why, and having one test that goes across multiple different levels of your program while also checking multiple different things could make them not only hard to debug, but potentially brittle as well. Go slightly nudges you towards this way of thinking by having the recommended way to organize your test files be by having the test files directly next to the code you are trying to test. I remember when I was doing Java back in university, we weren't really taught proper unit testing there, but I also kind of sort of remember it's like it was in a different section of the code base. So when I was originally learning the language, I don't think I had testing on the brain as much as I did when I started to learn Go. So next we're moving on to integration and end-to-end testing. I mushed these two together because the feeling towards them were quite similar, and end-to-end testing was sort of like an advanced integration testing-ish. So back to my diagram, it would basically be the test that check the connections between the things that are outside of your service. So HTTP calls or responses, queries to database, or inserting into databases, so on and so forth. Anything that requires your service to reach out to something else. And an end-to-end test is sort of the same, but now it goes across the entire platform. They are tests to check the connections and flow between the entire system. So the pain points of integration testing are similar to end-to-end testing, but on a larger scale, as it's no longer just how your one service connects to other things, but how your entire system communicates across everything. So what do people enjoy about integration testing and end-to-end testing? Well, the only one that really came up was that they are, in theory, the highest amounts of assurance when it comes to testing. If we imagine a perfect world where the services, databases, etc. you are testing against are exactly the same as the production environment, if your integration and end-to-end testing suite passes successfully, you'd have a higher confidence moving things into production than if you only had your unit tests pass. And they can act as an effective bulwark towards incidents in productions, because if your integration tests and end-to-end tests are against an environment that is effectively the same as production, the incident should already occur before it's merged into production in theory. However, this isn't always easy. Some of the pain points that people shared is that depending on the system, it can be incredibly difficult to write integration and end-to-end testing. Integration and end-to-end testing can usually involve interactions with services outside of your service, and you may have to consider things such as setting up and tearing down things after running the test suite, which doesn't really occur with unit testing. It can be complicated to set up and maintain the testing environment. Again, this is another thing that's based on the project or your company, but as an example, if you're dealing with a service that might call to a database where the query is like 100 lines long and hits many different tables and quite complicated, trying to set up the correct state in the testing environment could be quite frustrating. There can also be data drift between testing environments and production environments that can be hard to spot. Because of this, some tests can sometimes be skipped or maybe not done at all because it's just so difficult to test what you're doing in an actual environment that you choose not to test at all and just hope everything works fine. Now, this problem can be exacerbated in end-to-end testing, as although the above may be a simple example where it's just a UI service and a database that might be easy to handle and possibly easy to build and maintain, if we just add some random services in different areas and also extra databases, it suddenly becomes slightly more tricky to understand how exactly you might choose to end-to-end test this, and this isn't even that complicated of a system. Another pain point is third-party dependencies. What happens if, say, for example, you need to test against a payment service provider or just anything that you don't own? Maybe there's another team at the company and you have no access to anything that they work on. What happens if their service is down for whatever reason? Your tests are now reliant on things that may be completely out of your control, plus the way that APIs may be set up, it could be awful to work with and may even be documented terribly or maybe not even documented at all. And another thing that was raised was the idea that the more complicated the system, the more brittle the testing can get. Now, this is definitely more on the end-to-end testing side, but as shown before, that I just showed you, that wasn't a very complicated system. Systems today have hundreds upon hundreds of services all interacting and doing things. In a system like that, any number of requests could simply just fail for completely normal reasons, but doing so could mess with the end-to-end testing suite and make it a pain to work with, and it may sometimes never work. How many have been in a situation where it feels like staging is always down? So some of the remedies that were suggested was maybe the idea of allocating resources to assess and figure out how to reduce the pain. In some companies, there are specific teams and resources that exist whose sole purpose is to understand the health of the developer experience at the company, making sure the staging environments are stable and that there aren't hundreds of flaky tests that slow down development, and making sure developers have standardized testing knowledge and understand how to put together a test or build APIs and systems in a way that make it very easy to communicate with and test. Another thing that was suggested was maybe the idea of reducing quantity and increasing impact. How many integration or end-to-end tests that you are running are of high value? Do you need all the ones you are using, or could they be written in a way where they are impactful and not just numerous? But there was another aspect of testing that emerged because integration testing and end-to-end testing were quite painful to work with, and that was mock testing and contract testing. But this field has kind of sort of evolved over time, so I'm going to very quickly look at an older version of mocking, which is essentially the same drawing, except now the UIs and the databases are now just mocks. So this is something that you would create or generate yourself, and then you would determine what the responses are, and then you'd be testing against that. I sort of put mock testing and contract testing within the unit testing box as per my description. It's just you can run these by opening your computer and running the service. You don't need to connect to anything, so it's within it, but people sometimes separate them. So here's like a generic example of like what a Go mock would have looked like, although Go mock has no longer been maintained, and I unfortunately don't know what the current mocking framework is for Go, as in like what the main one people are using. But another thing that's come along is something called test containers, and it's like mocking has sort of evolved, and on their website, they call it as, maybe it's not called mocking anymore and it says no need for mocks, but essentially it's sort of the same thing, except now instead of it having mock in front of there, you now have a little Docker image, because within one test, as in the way it sort of works is like you sort of like, I'll just kind of describe it. Within one test, you can essentially spin up a Postgres instance inside a container, populate it with the tables and test data, and run the exact method you'd be using and get a real response as opposed to a mocked one that you built. All of this could be done locally and without the need to create or connect to a test environment. Plus, in theory, your tests could easily transition to integration tests because you'd be connecting to the external systems in the same way. And there's a lot more test containers can do that I can't really cover in this one talk here, but this could potentially be the way where mocks are headed, and the setup time would be similar to normal mocks, but the confidence might be better as you'd literally be running your local tests against the same systems your programs are going to be interfacing with. So as a random example, if there's an input you wanted to try out at an earlier stage of your project, prior to making an integration test, you could try that input and maybe get an error you weren't expecting that you can now deal with without having to have made a full integration test. Whereas if you were doing traditional mocking, you could have guessed what the output would be, but without that integration test, you wouldn't really know. So another side of the coin is contract testing, and that usually happens between service-to-service communication. It's a very similar vein to above, and I sort of see it like an evolved mock test. The main ones in this area appear to be packed. I couldn't find other examples, but contract testing has been around for a while, but packed seems to be the one that's like bigging up at the moment. And it might not be the clearest example, but essentially imagine you have two microservices and they call out to each other. You can actually do a call out, and then that creates a contract that details what the input and output of that, it basically records that input and output, and this allows you to have these verified contracts that you can test against without having to call out to the service again. And because in theory that service shouldn't update their APIs frequently, it means you can just keep working against this template that you have without having to constantly call out to something and hoping that it might not be down. So what do people like about mock and contract testing? Essentially, it provides a way to run integration tests with the same ease as unit testing. Once things have been set up, you can run these tests without having to make sure multiple services are running on your computer or that you're connecting to the correct place. It's all rather convenient. Another thing is that it reduces the reliance on other services in order to test your service. Say, for example, you have a connection with another team's service or they want to communicate with you. In the example of contract testing, you can snapshot those services and build against those snapshots. Now the other team can shut down their service on staging for a bit or anything that would have previously affected you, and you can keep working without needing to wait. So one of the pain points that was brought up with contract testing and mock testing is that over-reliance on mocks can lead to false confidence. Even in the case of test containers or contract testing, where you are very close to the real thing, it still isn't your system. There could be gaps in your armor that need to be tested properly. Ultimately, you still need to find a way to check the plumbing between the systems that you have in your ultimately you need to find a way to check the plumbing between each of these systems that you have. And in some cases, setup could be just as long as integration test. So some people voice their idea of why would we spend so much time like generating mocks when we're going to be doing the exact same thing again anyway. Some of the remedies that were suggested were the idea of maybe viewing mocking tools as ways to reduce but not completely replace integration testing. Perhaps the point of these tools is to try and get to the point where you can do as much as possible locally without needing a test environment, to speed up development within the team and to reduce frustrations, as instead of needing to rely on an environment, you can unit test instead. But you still likely need a way to check that the things you want to connect to for real actually connect correctly, as those things might have their own issues that your mocks, test containers, or contracts might not catch. The test environment could instead maybe become a place not to send potentially broken code, but to send code that's been tested as close to reality as possible, which may reduce the friction that could come with working with test environments and things like that. Plus, as you're testing close to reality, code replication may be reduced, though I think that might only be more to the test containers and contract side as opposed to the generating mock side. So this next one is about code coverage, which is a bit controversial in some circles, but I'm just going to be going over what people like about it, what people don't like about it, and I guess also talking about what it is if you don't know. For those who are unfamiliar, code coverage is essentially a metric that checks how much of your code is covered by tests. Depending on what tool you're using, you can run your test with code coverage and get a result similar to this, where it just says 100% of the files have tests, but only 50% of the code in those files have tests associated with them. And you might get something that looks like this, where you can see the paths, where essentially in green are the paths that have been tested, and in red are the paths that haven't been tested. So what do people like about code coverage? It is a good confidence builder at the surface level. Like say for example, you were to enter a new project and it had or a new team or a new company and it has like hundreds of thousands or millions of lines of code. If you were to run a test coverage street and it comes back saying only 5% of that code is covered via tests, you might feel less confident in that project and maybe even the team or the company, because that's a lot of untested code, and it could speak to some difficulties when it comes to maybe adding in new features, fixing bugs, or even introducing new engineers to the team. However, if the code coverage reported back was instead something like 90% of the code's covered via tests, you may have an increased sense of confidence in the code base. It can also help to highlight areas that are missable or difficult to test, As seen in the example, you can use code coverage to see areas or paths you may have missed when testing, and perhaps that area doesn't need a test, but on the other hand, you may have just forgotten about it. And on a personal level, it can be a bit of a feel-good statistic. Let's say you finally finished off a feature, put in the tests you think are required for it, and then you run test coverage and it says that 100% of all statements have been tested, and you can leave, move on because everything is fine. However, there are some pain points associated with code coverage, and the big one is that it can very easily be false confidence when you're using code coverage. Code coverage doesn't check if your tests are actually good tests. It just checks that when you run the test, certain lines of code are hit. That's all it does. You can very easily hit 100% test coverage and have completely useless tests. In the example I showed earlier, that's basically what I did. I just wanted a screenshot for the presentation, but nothing there was actually tested. And it's quite easy for code coverage to become an annoying blocker for people. A lot of gripes comes from the fact that a lot of the times it seems to be used as a target, as in you can't merge in your changes unless it has a 95% plus code coverage. So instead of it being a personal metric of sorts or a helper metric, it now becomes something you need to deal with in order to complete your work, which can make it annoying and could result in a lower quality of tests, because it can lead to bad testing practices if it needs to be circumvented. As I said before, it's very easy to circumvent code coverage, and if code coverage is no longer seen in a positive light in your organization, people will learn how to make it seem like their code has been tested, but not actually properly test the code, which could have some issues down the line. Someone brought up this quote about how when a measure becomes a target, it ceases to be a good measure, and that seems to be brought up a lot when code coverage is within the conversation. So some ideas that were presented to sort of remedy it was maybe the idea of making it less of a hard requirement, as in like code coverage shouldn't be a preventative to completing a feature. Someone who I talked to had worked in an organization where it was sort of monitored, but it wasn't preventative. So they were able to look at like the percentages of the code coverage as it went through, and if it dipped below a certain threshold, they might look into it to see if like, was it like a natural dip, did something happen, or so on and so forth. But it wasn't a preventative method to stop people from actually completing their work. And some people suggest the idea of maybe taking it back to being a personal win. As mentioned before, some people like code coverage as a way of finding testing paths they may not realize as their own personal measure. They just use the number as guidance to see if there's anything crucial they may have missed. So we're going to very briefly look into CI/CD because it's tangentially related, but it's going to be a much shorter section. The way I kind of view it is I kind of view it as a way to sort of like deploy and run and test code kind of things, but automatically somewhere else, and it's about standardizing workflows. And this is just an example of us deploying our website, our gophers.london website. And what do people like about it? Biggest one is that it's a bit magic, and that's kind of fun. Because I know when I first started learning Go, and I think it was before leaving university, I'd never done like an automatic deployment by myself. I'd just done like manual deployments. So when I was trying to get into the industry, I wanted to learn how to code in production, and I thought that meant I needed to know how to deploy my code automatically. So I built this fun little multiplayer server and put in this nice little game, and then I finally built like the deployment suite where it makes the tests and then runs the linter, and then finally it gets up there. And then when I did a thing and then like it launched on the website and I clicked refresh and it showed up, it was really, really cool to me at the time because presumably doing it manually would have been very painful. And when I got into my first Go job and I saw a much more advanced version of that, like all I had to do was push my code onto a branch, a bunch of magic happened, and eventually it would show up on the app that I was building. That's really cool. Another thing is that it can really help to standardize a workflow. You can choose what gets in and how something is deployed, and this can be standardized across an entire team or even company. What links you should use, like is it tabs or spaces, what tests should pass, how many reviews a PRs needs, or should it be added into staging first and then tested and then launched into production. The whole workflow can be standardized across everything. But another pain point is, as I just said, if it breaks, to a lot of people, it is magic. Using GitHub Actions as an example, you can take templates from others and use them in your own workflows. But if you don't understand why your workflow breaks, it can be very difficult to debug it. And depending on the complexity of the setup, you may even be stuck waiting on someone else to be able to save you, as only they have the knowledge of how the workflow works, which could be a bit frustrating. A remedy that was suggested in this is, like, as with most magic, the best way to make it less magical is to explain the trick, or demystification, documentation and education about the workflow processes. Just taking the time to ensure either you can explain the process you've created, or on the other side of things, the company takes the time or puts thought into making it easy for someone to understand how the workflow works and what it is and why it works, could be quite useful in getting people unstuck. It doesn't have to be a deep dive, but just some general knowledge could help. So now moving on to part 2, but don't worry, it's much shorter than part 1. So take a breath and let's carry on. Observation 1, oh wait, I didn't read that part. Don't take a breath. Anyway, this part is basically just a few random thoughts that cross my mind during these discussions. They don't really have a point, they're just thoughts, and that's it. Observation 1, it takes a village to add a test function. So remember this back simple function we did? What if this function was key to your service? At first, maybe you'll think, okay, all I gotta do is write a simple unit test for it, but as we've covered, there's a lot more to it than just that. You have all this other stuff to think about too. Maybe not for that function specifically, but across your service, you may need to keep a lot of this extra stuff in mind. Now, say for whatever reason, one of these options is not built in a way that makes it easy to work with, that can drag down the development process, because that function now has the weight of, as an example, oh shoot, how will I end-to-end test this, especially when our end-to-end tests are always broken and terrible to work with. This could perhaps hit your morale when it comes to developing new things or fixing older things. There are other issues as well. Learning all of these options isn't entirely straightforward, especially the correct way to do it, and that correct way could be completely different based on your project. In this presentation, I went over everything in a very high level, but I didn't discuss implementation details, and they each have implementation details that could again be different based on what you are trying to do, and it's a lot to have on the mind. Observation 2, your journey through tech has a big influence when it comes to developing a testing is good mentality. And originally I wrote it as a testing first mentality, but I guess what I mean by that is getting to the point where when you're creating something, understanding that the test, that it needs to have tests in order for it to be done, and unlocking that type of mentality. What I mean is that there is a plethora of companies out there, and I'm sure there are people who have experienced or worked with companies or people who did not have a good attitude towards testing, or whose testing environments were not very good to work on or with. But if I recall one of my earlier positions, there was literally only manual testing via scenarios, and you had to upload those test scenarios to Jira, and then run through the scenarios, and then tick it off in Jira, and I wasn't even taught about unit testing or testing frameworks or anything, so I didn't like doing any testing because it was awful. And it literally wasn't until a few more jobs down the line when I was using Go that I had the opportunity to sit next to someone who could teach me a bit about how to properly test what we were working on. But at that point, the bad habit had already been ingrained, and so when working, I just wanted to be done, and testing was not a part of that doneness. Conversely, there now exists this fun resource created by Chris James called Learn Go with Tests. Now, the reason why I bring this up is because someone who I spoke to this year had the opportunity to start their Go career working alongside Chris James. So you can probably guess their attitude towards testing was a lot healthier than mine at the exact same points in our career. And as they move through their career, they'll have this positive experience to reflect on, and it could shape how they build and work on future projects and their reactions to working on projects that might not take the value of testing into consideration. Who you work with and where you work, at least at the start of your career, can be entirely up to chance. Even if, say, you landed in the best company, who's to say the team you end up with or the way the company-wide deal with testing may shift your viewpoint towards it being another chore to get through instead of it being an important and critical part of the software engineering process, where being done includes having tests as well. Observation number 3, there is a correlation between a good testing experience and a good developer experience. Testing is sort of part of the software engine, it's just part of the software developer experience nowadays. And I know I just spoke of a place that did manual testing, but as I said in my talk description, testing is inevitable, but whether or not it feels good seems to be optional. I was talking to someone who's working in a place where they have a plethora of known flaky tests, and it can take them hours to merge a feature, and they've started to slowly dislike where they are working and have started to care a bit less about the things they are working on. I feel by not prioritizing the testing experience at a company, it could eventually bleed into your developers not enjoying working at that company, especially if testing starts to become the linchpin in every single thing that is being developed. Conversely, I think a good testing experience can maybe build morale and confidence within the company as you sort of naturally start to create better and maintainable code because it's part of the culture, though again, this could just be correlation. And finally, in software engineering, testing is a second-class citizen, but I think that's changing. What I mean by this is that when you're learning how to code, at least in my experience, I don't think testing is brought up that much. Like you can follow tutorials online and things like that, but how you test things, how you test the things you are learning how to build doesn't really come up as often as, well, I guess it should maybe, and it's definitely seen as like more of an afterthought. The Learn Go with Test course that I just showed, that I just mentioned earlier, is definitely more of an outlier when it comes to introductory courses. However, the same could be said for programming languages, as a lot of languages do not have testing built in. You have to install a package, and for some languages, there are multiple unit testing packages, so you're now stuck at a decision where if you're learning, how do you know which one you're supposed to use and which one is being used like in production in companies around the world. However, this does seem to be changing with new languages such as Go, Rust, and Zig as they have inbuilt testing tools. And as mentioned earlier, Go has the best practice of putting test files next to your files as you're trying to test. And all these things can help keep testing at the forefront of your mind. And coincidentally enough, these seem to be languages that people seem to enjoy. And as time continues, perhaps testing will become part of the path to learning any kind of programming, so the testing mentality just becomes something that is learned naturally as opposed to by chance. So now we're going to move on to some very quick conclusions. There was a lot to talk about on this subject. When you talk to a bunch of different people, you get a lot of information, and some of it, unfortunately, does not make the cut. But for the things that did, it was definitely an interesting write-up for me. But if I had to sum everything up in a very short slide, ultimately, testing is part of the framework that is software development. So if you can, try not to forget about it and try to make it fun. Anyway, I've been me. Goodbye.
Any questions?
Hey, thank you for the talk. Lovely, lovely subject there. I do have a question, maybe it's related to the people that gave you feedback. I'm curious to know if the topic of VCR testing or golden files were mentioned by the engineers that you had a chat with.
By VCR testing, do you mean that there was that one package called Go VCR, right, where you like record the HTTP calls and stuff?
Yeah.
Well, I can use my own experience. No one I know talked about it, but I experienced it once.
Ouch. But yeah, that's good.
But yeah.
Thank you.
Wait, was there a question or was that just a statement?
No, it was just a question. I did want to know how many people maybe mentioned or did not, but
so
sounds like they did.
So 1 out of 30.
Lovely. Thank you.
You talked about the pain of flaky unit tests or tests in general. What is your rule of thumb when to delete them or deactivate them?
I think the general rule of thumb, because I talked to one person and they kind of said like they have like a flaky test squadron, as in there is no flaky tests allowed in their entire system. If one shows up, they drill it down until it's gone. I might join them on that squadron, but I don't work there. But it seems like a good idea because in the other place where they have like hundreds of flaky tests, the person who I was talking to seemed depressed. So maybe we should get rid of those flaky tests.
Cool talk, Benjamin. Thank you very much. My question is, did anyone mention things like acceptance testing, things like Cucumber or Fit, where you're actually testing the requirements and not just the implementation of them?
Weirdly enough, no, but that's another thing that I've also experienced. But like, unfortunately, the people I talked to didn't bring up things like Cucumber or scenario testing. I don't know if it's running out of favor or if people are still using it, but the people I talked to just didn't bring it up.
Thanks. I suspect the farmer.
Oh, fair enough.
Did anyone talk about pain points writing tests for asynchronous code, for concurrent code? And because often I found that the flaky tests often come from that, because you have to have some kind of timeout, and sometimes the negative tests, you're like, oh, I have to wait some time before something doesn't happen. And then, in CI, maybe it really does happen, there's...
Unfortunately not, that didn't come up, but can I ask you a question?
Sure.
How would you recommend dealing with that problem?
I just have some flaky tests every now and again.
Oh.
I mean, I haven't found a good solution, which is why I'm asking. Really. I think you kind of have to have some kind of... You can try mocking time, but that leads to all its own problems. Right? So there's a whole rabbit hole you can go down.
Okay.
Little used race flag.
Oh, you can use the race flag. Wait, that sounds awkward from the shoot. Cut that part. Cool, I think we're good. Bye. Bye.